Oh, okay, awesome, yes.
And I'm expecting to do a PhD fortunately in resources.
Oh, that's fantastic, yes, okay, excellent. Yes. Yes.
Okay, so I think we can get started. There are still some people maybe coming, but let me welcome at our center for our Geospatial Forum Professor Alexander Klippel, who is Professor of Geographic Information Science and Affiliate Professor of Information Science and Technology at the Pennsylvania State University. He is the Karen Gosnell Senior Faculty Scholar in the College of Earth and Mineral Sciences, and he has been named the inaugural director of Penn State Center for Immersive Experiences. So I think you're building a new center there.
I'm collecting inspirations from you guys, so yes,
Yeah.
including the branding, so that's awesome.
Okay.
So,
Alex earned his PhD in informatics and mathematics in 2003 from the University of Bremen, Germany, and he gained postdoctoral scholar experiences at UC Santa Barbara and University of Melbourne before he joined Penn State in 2007. He founded, and you need to say, how do I read it?
Oh, Chorophronesis.
Chorophronesis,
Yes.
Applied Spatial Intelligence, a research team focusing on advancing applied and basic research on immersive technologies as augmented and virtual reality. And I think what's really interesting, what wasn't really in the flyer, and I wish it was, is that he has a lot of experience in projects in cognitive science.
Oh.
And his focus of research is in spatial cognition. And I think we had some people here who are really interested in there. So with that, please welcome and let's hear your presentation.
Yes. Great. Thank you so much. It's fantastic to be here, and I really meant it. I already had so many inspiring conversations, and visiting your center really has left me with a lot of ideas for what we could do with the center that is officially launched at the end of this month. I put together a number of the projects that we have been running that center on place, and I think that most of us can agree that place for anything geospatial has an important, or is an important meaning, an important concept. This is just a flyer from a seminar that I almost gave this spring, so I will try again next spring again, where we talked about place, and place as this combination of a location that has meaning. What I find particularly interesting about this approach is that it is not something that speaks to only the social sciences, but it also speaks to physical sciences. So physical scientists go to places, value being at a place, immersing themselves in a place to develop a deeper understanding of, for example, processes that help shape a place. With immersive technologies, which we can organize, for example, along this continuum that has been made famous by Milgram in 1994, the virtuality continuum, including everything from augmented to virtual reality, and sometimes we now use the term mixed reality because of the sophistication with which we are able to scan environments and to integrate digital content into actual environment. With immersive technologies, we are able to bring remote places that are either distant in terms of temporal or spatial aspects into research labs. We can change them, we can offer new perspectives that have not been available so far. So there are two things about immersive technologies that really make them different. One is actually this aspect of being immersed in the data. So this is something that is almost completely new, at least at the scale that we see it at the moment, that we can actually become part of the representation rather than being separated from it. So instead of seeing data or any other thing that we represent, that we collect data about on a screen, we step into the data, we are surrounded by the data, and we become part of the representation and can directly interact with it. So that's essentially already the second part. So the aspect of immersion as well as the aspect of being able to interact with the data. There's a nice figure that I took from the internet and I credit it here. So I hope that that's okay for your YouTube production. That is symbolizing this idea of presence. Presence is the sense or the behavior, the emotional response to being immersed. And the Chinese symbol for presence, and I'm not sure that it's entirely true, but it's a good story, comprises the different senses that then contribute to presence. So our auditory, our visual senses, but also speaks to a deeper level of sort of the emotional connection that we feel. And then what I find particularly important is the undivided attention that we can have while being immersed at a place. So I think that this is something that, again, immersive technologies are good at, that they really capture in the way that they deliver the content that other technologies so far have had a challenge of delivering in the same way. The one thing that, again, making a point about the possibilities is that so far we have primarily seen sort of capturing the real world, or we have seen sci-fi movies that allowed us to take a different perspective. With immersive technologies, we can do exactly this now at the level where we take our bodies into that experience. So the sci-fi movies like Ant-Man or the Fantastic Voyages for those slightly older generations, so is something that, that we can actually now bring into a lab space, bring into experiencing data, bring into experiencing places in sort of from different angles that have not been, that we have not done so far. So with that little prequel, so I will talk about two things. One, I just show you a couple of the workflows that we have been developing, and then the main aspect that we're doing is actually empirical evaluating immersive experiences, to essentially being able to separate the wow effect, the novelty effect, the awe that we all experience when we put on a headset from the actual effectiveness and efficiency of this new medium in communicating, in helping us to make decisions. So the workflow, I've brought two examples. One is a immersive workbench for geosciences. So for this project, we used data from a colleague of mine, Pete Lafamina, about the Trinukagigr volcano on Iceland. It's actually a dormant volcano, so it's not quite as spectacular as it sounds when I say we flew drones into this volcano. So it is actually a volcano that has an elevator. So in addition to actually flying a drone into the volcano, he also was able to haul down terrestrial LiDAR equipment into the volcano and then create measurements. So what we did was we pulled the LiDAR data as well as data from photogrammetry into Unity, a game engine that allowed us to design a system around the data and to perform or help people analyze the data in this kind of immersive new way. So this is an actual DEM from Iceland. The sky is something where the students got carried away, so that's not the traditional Iceland sky, but that's okay. So it's a creative freedom there. It's a little bit slow at the beginning as well, but you essentially can then select the volcano and be inside the volcano. This is the LiDAR point cloud with the colors being the different intensities of the LiDAR reflection. We then have a work solution in form of a menu where you can then make use of all the advantages that digital environments have by providing additional information, by reclassifying, for example, the LiDAR data by switching back and forth different styles to select whatever works best for a particular type of analysis. So here, the switch between the LiDAR model itself and then the photogrammetry model. And the quality is a little bit better on my screen than on the big screen. So with the developments that we see, we can essentially create more and more realistic environments in here. We can perform all kinds of measurements, so such as measuring distances. Immersive experiences are actually the only form of representation that allows us to experience what the actual size, the actual scale of an object is. There are of course limitations, and of course if you are interested in cutlery, you can of course have also the one-to-one scale on a computer screen, but this structure of the volcano is about 600 feet. So in the immersive experience, you can actually blow it up to the actual scale and then really experience it as it is one-to-one, which is not possible essentially in any other digital environment that you put on a screen. The second project, and I talked about this quite a bit with several of you this morning, is an NSF project on visualizing forest futures. It's a project that is located in Wisconsin, and it's together with the Menominee, who are very much into forestry, and forestry is a very central part of their cultural heritage. It's a project that we have together with Rob Scheller and Melissa Lukasz and a couple of other people. What we try to accomplish in this project as one part is to translate abstract data that we get from models such as Landis into something that becomes experiential. So many of you know Landis a lot better than I do. It's an ecology model that takes, for example, input from climate change model and then produces output that gives us an idea of how certain tree species, for example, behave under climate change. The data that you normally get from Landis is that for each map cell, you get biomass for a particular tree species, which is rather abstract. So what we were asking ourselves then is, what do we need to do in order to translate the abstract information into some parameters that allow us to create a 3D model and then also turn this 3D model into something that we can experience. What we used is the FIA database, the Forest Inventory Analysis program, that has 4 specific plots: species, age, biomass, height, crown width, and the number of trees. 4 specific plots. By regressing over this information, we were then able to translate the data that we get from Landis into the parameters that we need for the actual experience in form of species, tree height, crown width, and then also number of trees. So this is a very small plot that from an overview perspective, but if you actually zoom in, you get actually the chance to see a forest or see the data as it would be, for example, in 2050 under certain climate change scenarios. We are currently working on turning this into an immersive workbench as well, so where you can, for example, switch on and off certain tree species, look at the landscapes from different elevations, and make the whole thing interactive as well. I have a short video. It's not the most recent video, but it shows that we're not Pixar, so, but the quality that we can actually produce as scientists in these projects or in these kind of workflows is actually quite substantial. And with all the discussions that we had this morning already about Blender and other software, so if anything, it will become much, much more accessible. And this form of communicating results from scientific analysis is something that is really in the grasp of many more people these days. The forest of the future doesn't have watermarks. That's just because we are cheap. So we just use the educational version and not the paid $3,000 version for this. Okay, but yeah, you can make it interactive. You can use it for educational purposes. You can compare different scenarios. So for example, with and without climate change. You can focus on particular tree species. You can give different elevated perspectives. So all of this is possible as a very new form of interacting with a place that we have not had a chance to experience because it is in the future. So we do these things, and I with the examples, I almost stop here. So for all kinds of different places. So we have projects where we create immersive experience for wetlands. Oh, I have to. For wetlands with just a drone image here, and it's we do primarily 360-degree images. We have projects on energy, so this is a fracking site in northern Pennsylvania. We do immersive experience for fire ecology in California. This is the Ishi Wilderness in the Lassen Forest, and we also had a fun project with the Mayan ruins in Belize. This is Chinantunich in the central lowlands of Belize. I have a short video of a slightly different approach. So often what we do is we have these kind of map examples that we use to contextualize these tours. What you see here is just an example of one of the actually apps that we create. So it works on Android phones, Oculus Go, or on high-end HTC Vive versions. What you've just seen is we experiment with all kinds of aspects that we can integrate here. So for example, offering elevated perspectives. We have a 27-foot tripod that we often take into the field to give an overview perspective if we're not able to fly drones. And then what you have seen here as well is that this new medium actually requires thinking of how the communication storytelling works. So if there is, for example, a particular location that you want your audience to focus on, you need to find a way to actually guide them to that location. Because the beauty of the 360 immersive experience is that you actually give your audience agency in deciding to where they want to look. The downside is that they can take this agency and look wherever they want, so they don't necessarily focus on what you want them to focus on. So we started experimenting and implementing these visual guidelines that help users to then also follow, for example, a narration in a way that you normally would follow if you just watch a video where you're kind of confined to a single perspective, this perspective of the camera. Okay. More importantly, so the empirical evaluation. So, and I picked out one of the main research thrusts that we currently have, and that focuses on immersive virtual field trips. So immersive virtual field trips, just as the beginning. So normally when we try to educate students, you have these beautiful spaces here, but a lot of the times we have crowded lecture halls, and especially if you talk about something that happens in the real world that's relevant for a particular place, you much more would like them to actually take them there, contextualize and scaffold the learning content with the relevance of the place itself. In beautiful State College, my colleagues do that, but with limitations. So normally you have lab periods of 2 hours, and that means that you have a 12-mile radius of the sites that you potentially can take students to, or you have to use the spring break or the summer break for extended periods. So how can we scale this? So we thought about this for quite a while and came up with some alternatives, and then also a research framework that allowed us to kind of structure not just the development but also advancing sort of the science behind how we deliver these kind of immersive virtual field trips. This research framework has two components. One is what we call a taxonomy, or the virtual field trip taxonomy. And that's relatively straightforward, so it's nothing dramatic. So we make a distinction between basic, plus, and advanced virtual field trips. A basic one basically would replicate the environment as it is. So that's the most straightforward way of capturing sort of a particular place. The plus one allows for capturing the environment, but from perspectives or in a way that is not possible in physical reality. So in this case here, it's a ground perspective, and then on the right side there's an elevated perspective. In case of this outcrop, you see that when you elevate the perspective, you all of a sudden see the outcrop in a very, very different way than you would from a ground perspective. And the same thing is true if you have a drone image and, for example, see how a wetland is embedded in the actual landscape. Additionally, you could imagine bringing two sites together that are normally spatially distant to compare them directly. Still, all of those things are possible with capturing what the real environment actually looked like. So potentially very minimal development cost. And then the advanced version, I'm trying to press the wrong button. The advanced version is then where we have simulations, for example, about a future state of environment. And I showed this before. So if you have a climate change model that you use to feed information into an ecology model and produce output of, for example, a future state of an environment such as a forest, that would be sort of the plus version. Again, with immersive technologies in combination with the 3D modeling advance that we have seen at the moment, it is possible, but it requires a fair bit of development cost. The second component of this framework that we have developed is what we call Sensatium. So it's a bit of a mouthful. So it's the sensing scalability trade-off continuum. So yes. So what this essentially captures is that we have, so if we talk about sensing and sensibility, then we have a low-end version, such as an Oculus Go, that has 3 degrees of freedom, where you meaningfully can turn your head, but you not can meaningfully do any lateral movements. It just doesn't capture that particular movement. On the high end then, or moving towards the higher end, we have things such as an HTC Vive, we have body tracking, we have eye tracking. So we can integrate a lot of sensors into the experience that then also allow for tuning and tailoring the experience to the user and the user experience itself. Of course, with the development of an Oculus Quest, for example, we move sort of the lower end spectrum to the higher end spectrum as well. But the point is, and that's why we organized it as a coordinate system, the point is to be able to say, how much do I need to actually invest to get learning output that I desire? Right? So can I deliver a learning environment, a learning experience, or a decision-making experience with the low-end cost, with a low end, with the basic version, or do I need to invest in high-end gear, and do I need to invest in creating and curating high-end simulated advancements of sort of environment in the future? So this curve is sort of the trade-off curve between sort of making things more expensive and less accessible, or vice versa. And of course, it could also be in the extremes. So we could find out that we really just need an Oculus Go to achieve our goals, or we find out that we really need both a very advanced and a very high-end system. The numbers that you see in the middle here, those are the experiments that we have run already. So we started in 2017. It was actually an HTC Vive and basic version, and then we have advanced this to the plus version, and I come back to that. And then we also reduced it again to go when the Oculus Go became available last summer, to develop for a low-end version as well. Again, with the idea of, so what do we need to do to scale this up to make this a more regular experience in the classroom? Then I'm not going into detail there too much, but we also create spin-offs in terms of singling out particular aspects that we then address in very basic research experiments and basic research setups. So for this first field trip, it's called the Reidsville Bald Eagle. So if you're into geology, it's a formation in Pennsylvania. We had an actual field trip and a virtual field trip. So we used a introductory geosciences class that allowed us to split the class into 2 groups, where then one group would go into the field, the other one would go into into the lab so that we could actually make experiments, a comparison. This is the, oh, I should press the wrong button. The field site from above. We used a combination of 360 images. So this is the numbers that you see here. And then at location number 6, we also used a 3D model derived from structure for motion so that the students were able to do the exact same exercise that they do in the field as well, which is measuring the widths of the rock layers to create stratigraphic maps. The students were, this is just the outcrop from the side, from the distance. They were able to use a Google Street View-like navigation between the images in form of arrows that only were available in the order that they would normally go on the actual field trip. There were parts of the outcrop or in the images where they were able to get more information, again, information that they normally have in their lab handbook that they can use, for example, to classify different grain sizes. And then this is by example of the outcrop there where we created the 3D model where the students then measured the width of the rock layers. They collect the data, it's recorded and then sent to them by email at the end of their experience so that they were able to do their homework in very much the same way that students in the actual future were to do this. So what are the results? We find that if we ask students about their self-assessed learning experience, that the students in the virtual future actually significantly more agree with the statements such as, I learned a lot from this field trip. We also have composite scores of overall enjoyment. For example, we have 4 different questions that we ask. If we take this together, we also find that students are much more happy with the virtual field trip compared to the actual field trip. And then one thing that we were very surprised by, because our minimum requirement was that this should at least not mess up students' grades, is that in this first experiment, students' lab grades were also higher than the ones when they went to the virtual field trip compared to the actual field trip. There can be lots and lots of reasons, right? So it's not just, hey, I put on a headset and then all my problems are gone. So there are no mobile phones in virtual experience, at least we didn't program them in. So there are lots of things that are sort of additional factors, but we definitely met the bar with, or exceeded the bar that we set ourselves with this study. We also replicated this study. So in the spring of 2018, we had slightly more or higher number of students. What we also did is we moved the basic virtual field trip into the realm of the plus virtual field trip. So in the first one, we only had ground images. In the second one, we had an option for the students to go to the elevated images of 27 feet high. There's a quirky thing here that happened, and it was a different instructor. Extremely supportive, gave clicker points and everything, but had the request that all students need to go to the actual field trip and not just into the virtual field trip. So there's a very, very strong belief in the physical sciences that you cannot deprive students from going into the field and quite literally getting their hands dirty, which has absolute merits. So what we did then is that we had basically the virtual field trip as a additional requirement or additional preparation for the actual field trip, which also allowed us to ask slightly different questions, such as how well did you actually feel prepared for the actual field trip? So what we find is that there was an overwhelming sort of enthusiasm on the side of the virtual field trip participants that they actually felt a lot better prepared for the actual field trip. Everything else would be very surprising if they didn't, because in addition to the lectures, they went through this virtual field trip. But if anything, it is something that even students or even instructors who believe in going to actual field trips, if they really want to prepare their students, they could spend half an hour in a lab preparing them through, for example, a virtual field trip. We were able to replicate most of the other findings as well with great success for questions such as I learned a lot from the field trip, as well as the overall enjoyment. Where we did not find differences this time, just a slightly better value for was the lab grades. Which again, lab grades are a very crude instrument. And they did the lab homework assignment after they basically went through both experiences, as well as lab grades have sort of a certain tendency to be sort of inflated. So we are working on a more rubricized version of lab grades that allow us to answer more in-depth question. The one thing that I would like to single out here, so that's the question of what does actually going to the plus version mean? And what we see here is a very sort of simple way of basically getting onto the 27 feet perspective. So students were able to look up. There was a red disk. They clicked on the disk and then they had the overview perspective from 27 feet height. We measured the response to that through, I'm still pressing the wrong button, through a very slow learner. So we measured the response to that through a construct that's widely used in the media psychology. It's called the Spatial Presence Questionnaire. So it essentially assesses how present, after exposure to a medium, students feel about a place, for example. So what we see here and what we compared is, so the AFT group is the first actual field trip group. We saw an improvement between the actual field trip group and the basic virtual field trip group. If we then add the elevated perspective, what we find is then actually a statistically significant difference if we compare the plus version, so the one with the elevated perspective, to the actual field trip version. So by giving students access to perspectives that are not possible in the actual real world, we can enhance their experience, we can give them a better understanding of the environments. And I will come back to that. We are actually now running experiments that help us then to really quantify, not just in terms of a qualitative assessment, but in terms of actually objective metrics, what this then means in terms of spatial learning. We continued with this study, and in the fall of 2018, we ran the study again as what we call it immersive learning in the wild. The reason why we call it like this is that, again, a quirky coincidence brought us in the fortunate situation that there was no actual field trip possible anymore. There is construction going on like everywhere, and they widened the road, and the actual field site is a blast zone at the moment. So there's no replacement for it. So the course actually did not have the chance to send anyone into the field. And we said, hey, we have a virtual version of it, so why don't you take that one? In the fall it worked. It does not always work. It's kind of amazing that even there's a very, very intense belief that no, you cannot just have a virtual version. So we're working on that. But in the fall of 2018, we had out of a sudden 76 students that needed to go through the experience. So in order to manage these higher numbers of students, we did two things. One was that we used all the actually publicly available VR spaces on campus. So it's not our lab anymore. It is a place called the Dreamery. And if you know Penn State, there's a place called Creamery, so they had this wordplay with this. It's an emerging technology environment where students can go and where they have an HTC Vive. We have an IMAX, an immersive experience laboratory, where we had Oculus Go, so we developed a virtual field trip for Oculus Go's. We have a VR room in two libraries, the Paty library, which is the main library, and then also our Earth and Mineral Sciences library. So students, instead of coming to our lab, actually went into publicly available spaces, signed up for a slot, and went through the field trip. So that's the ideal situation, because that's basically sort of the long-term goal, that we don't have to administer all the virtual field trips, but that instructors basically can sign up and send their students into these rooms. So this is just an example. So we had to rethink the design of some of the activities. The 360 images are very easy, but then the measuring that required a little bit more thought through because it was just a single controller that has very different forms of sensing than, for example, being able to use an HTC Vive controller. We managed to do that, and this is just an example of how students on swivel chairs would then have the experience. So in this case, we were not confident having like a number of students just standing around and potentially bumping into each other. There's a lot of things to say here. And as I said, it's really in the wild. It's a study that had 76 students. Of those 76 students, 44 actually agreed to participate in the study, largely because they had to fill out a questionnaire before they came to class, so which has the consent form. So they filled out the afterwards form, but they didn't fill out the form that we sent to them by email, right? And then we had 4 locations, so 44 students. We had actually 26 in the, or 25 in the Go version. So it's a too small number to make anything out definite. But what we were actually experiencing was something that we did not expect, and I just show one example. So this is comparing the learning experience, so the self-assessed learning experience of the 3 different semesters in which we have run this. And again, there's a lot more to say about this, but what we see is that if we really roll out, so this was the first, then we had the second one which was slightly improved, and then these 2 are the ones that were in the fall with the entire class. So what we see is that that the Vive, so this is the rooms where the students went into all by themselves, actually had the worst outcome. So students, at least when they're not having had this experience, being sent into a room in the library did not work particularly well. There's also a kind of a quirky bias in here in that, so we did the pre-assessment and post-assessment, that there was a higher number of students who were skeptical about immersive experience to start with, because it was the entire class, so it was not a self-selection or volunteer basis anymore. So we had a fair number of what we might call sort of hardcore physical scientists in there who don't believe in immersive experiences, and because they were able to sign up by themselves and we have small numbers, we had a much larger number, I think 7 compared to 2 in the Vive version compared to the Go version. The Go version also was a group experience, so the students were there, an instructor, one of our lab assistants was there and really gave them sort of the tour. So it was an overall very different experience than just being by themselves in the lab. So the bottom line is that if we really want to roll out immersive experiences as sort of a large-scale learning experiences, that we have still a fair bit to go, and that it is simply not quite for everyone. For students who like it or who are open to it, that's definitely an excellent opportunity. What we had hoped to do this semester, but what got postponed for organizational challenges that we were facing, is to actually have a class with more than 1 immersive experiences. So in the fall, we will have a class where students go through 3 virtual field trips. So, and that then will allow us to assess whether these curves go, for example, up or down. So if someone, so the awe effect, people put the headset on and say, wow, that's so cool, might go down. But then sort of being sent to the libraries by themselves doing a field trip actually might go up, because when they do it the second time, they say, I know what I'm doing. So, so there's a lot of things that will potentially change if we now really use these immersive experiences as large-scale, in the wild kind of experiences. So just very briefly, a couple of, I'm still pressing the wrong button, so it's very hard. So a couple of current developments that then also spin off into what I said, that we single out very basic research questions that surround not just immersive field trips, but all kinds of immersive experiences. So one thing that we have started looking into is locomotion in VR. So if you have a VR experience, in most cases your physical space is smaller than the space that you're representing. So if you have a forest or an outcrop, so even if you have a detailed 3D model, eventually you run into the wall. So you need to come up with some form of locomotion that allows you to get from A to B if B is outside sort of your actual physical space that you have available. So people have come up with all kinds of funky solutions that you can do to get from A to B. What we did is we looked into, I'm still pressing. So what we did is we used the standard versions that is available in the Vive, and we actually implemented this into the desktop as well. So what most people know from playing computer games on desktop is that you have continuous translation. So you have a movement that is smooth, that is continuous, for example, using a mouse and your arrow keys. In the HTC Vive, if you do that, you definitely get cyber sick, motion sick. There's a trick that Google implemented, Google Earth VR, where they reduce the field of view and they blur the ground if you're moving. And that actually does the trick, but that's only came up after actually we did the first experiment on this one. Or the alternative is you can reduce the motion to something that's a meter per second, so it's really, really, really slow. In the Vive, the most common form is the teleportation. If you do teleportation, though, you lose a lot of information, right? So the information that we're normally used to in form of optical flow is not present anymore. But you have the headset on and you get a lot of proprioceptive information about the environment as well, because turning your head is actually meaningful too. So we were actually kind of convinced that the Vive, again, you put the headset on, you say, this is so cool in comparison to just looking at the screen, would outperform any desktop version. And of course, we were proven wrong. So this is actually not the case. So in this case here, up is actually bad. So this is the error that the participants made afterwards. So they learned an environment which is called Silkton that we re-implemented into a Vive environment where you learn landmarks along a route and then landmarks between two routes. The green is the HTC Vive version, and then the blue ones are the desktop teleportation as well as the desktop continuous translation and the continuous motion. There are no statistically significant differences, which is good, but if anything, there was sort of a concerning sort of increase in the pointing error that the participant made in the Vive version. So what this ultimately means is that as awesome as it is to be immersed, if you combine it with a form of locomotion that we are not used to, you might actually lose the advantages. We're currently trying to explore this in greater depths. The other aspect that I briefly wanted to mention is scale. So I mentioned that when you basically give someone an elevated perspective, you increase the scale that is accessible to a user at a single vantage point. And that is awesome because it allows for offloading information that you normally need to keep in your memory, in your working memory, into the environment. We have seen that it had positive effects in the virtual field trip, so we designed an experiment that is more controlled in form of a maze. So the maze has, again, the same two distinctions, ground perspective and an elevated perspective. At the elevated perspective, the number of landmarks available is increased so that you can actually see more than one landmark at the same time, which we thought would help students to create a better mental representation of the maze. We are currently rerunning the experiment as well to increase the number of participants that we have. And we're also currently running an experiment where we only have the elevated perspective but not the ground perspective. Because what we found is that a lot of things actually were as expected. So what you see here is that we separated the participants into a high and low spatial ability students, and the light blue ones or the dark blue ones, the highest spatial ability students outperform the low spatial ability students. But what we see, and again, although there's no statistically significant differences, is that while the low spatial ability students actually did show an improvement when we gave them the ground and elevated perspective, the high spatial ability student actually did not show an improvement, and if anything, they got worse. We did this actually in 2 trials, so we also find that students over time get better, but again, this also replicates this finding that especially the high spatial ability students did not improve drastically. What we had to do though is, again, so this is then sort of the nitty-gritty parts of designing an experiment where you don't want to change things that are not part of the experiment, is that you actually need to keep the time constant, right? In order, you don't want to give students who also go to the elevated perspective more time. So what we actually find is that, so if you go through the maze and then you have to split your time at every other location to go up and down again, that actually, so we measured this as well as a cognitive load, that actually increased the cognitive load of the participants. So as well-intentioned as giving elevated perspectives is, if you put it into this kind of rigorous context of an experiment, of a controlled experiment, it actually might not turn out the way that you do. So we're currently running the experiment again with just the elevated perspective, and then also have another paradigm that we are using where students have free exploration, and basically we measure the time it takes them to learn this environment. So again, it's something that I think is a very important message, that as much as we love the immersive experiences, and obviously I'm an advocate for them, it is not as straightforward to show that they actually have the advantages that we would like them to see. How am I doing on time?
Yeah, pretty good. We still have about 10.
Okay, I can stop at any time. So one of the things that, again, I just wanted to briefly show as a development is that we also develop joint experiences. So we have, for example, connected 12 to 15 Oculus Go's into the same experience. So we just ran a study on that with the energy side that I showed at the beginning. So how this looks is that you essentially have a lead client and then you have a following client. So this is the lead client and this is the following client. It's the same principle with the difference that the lead client now can basically, or is in control of the location. Again, the lead client is not in control of where the student is looking, right? So this again then requires thinking through, so how do we get students to focus on the aspects that we are actually talking about. So what we implemented is, and that should show up in a second here, is this pointing mode that, is it ready? Yeah, so it's the pointing mode. So the lead client basically can set a location that's of relevant in the experience, and then the following client would see the arrows again coming up, guiding the participant, the user, to that particular location, and that's something that again for an experience it's essentially like Google Expeditions, but flexible, and we can use our own content and we can do our own development. So that has been working particularly well for the energy side. How much mental capacity do you have? You have one more video? Okay. So something completely different at the end, but with also an important message. So we did also a study on second language learning. Right? So language learning, again, is best supported by immersing yourself in the environment where you want to learn the language of, right? That's why we send students overseas to learn the language rather than studying a book. So the same could then apply for creating immersive environments that are more flexible, that allow us to immerse ourselves in that environment. So we did that, and we created 2 environments actually. One is a kitchen that's fully interactive, and one was a zoo that was not interactive. So because you don't cuddle with crocodiles and tigers and lions. So, but the kitchen is interactive, so you can switch on the water. Again, it's the interactivity is not with gloves; it's just with the controllers. But you can point to objects. It then reads the name in Mandarin, so to you. You can, yes. Strangely enough, most people like to trash the kitchen, so it's really it's one of those urges where I say, oh, I can't throw these things around. So that's we have done not any studies on that, but I would say that 70% of people at some point discover, hey, I can throw this stuff. So and that's basically sort of the general setup. And again, without going into too much detail, so one is the kitchen definitely performed better than the zoo. So adding this interactivity was helpful. And then the most important thing that I just wanted to briefly point out is that we did not find, so we found differences, but only after we split the group of participants into, again, high and low achieving students in terms of language learning. So we assessed this before they did the study. So what we find is that if students have sort of a high aptitude for language learning, then it doesn't matter what kind of environment we give them. And actually what we gave them was not a textbook in comparison, but we gave them the same environment as a desktop experience. So putting on the headset for high achieving students did not make a difference. For low achieving students, though, we do find that students with the virtual realities, the blue one, actually had a significantly higher score than the students with just the virtual world, but accessed through a desktop. So another important thing, that certain learners or certain decision making might be best supported through an immersive experiences, but it may not be sort of the one size fits all for everyone. Well, that's essentially it. So I thank you for your attention, and I thank all my collaborators and especially all my students, without whom all of this would not be possible. So thank you.
Thank you for the fascinating presentation. So I think we should have a lot of questions. Yeah, okay. Now, he's geologist.
Yes, yeah. Oh, yes. Yeah, so, yes.
So, yeah,
yes.
Being out, someone who likes to go outside with
Yes.
students, right? Part
Yes.
of the thing about being around an outcrop is you can ask the students questions.
Yes.
Get their responses, correct their
Yes.
misconceptions.
Yes.
What do you see the kind of ability to do this in the VR world?
So this is essential. So there are two routes that we try to explore at the moment. So the quote unquote easiest route is the joint experience that we developed, and that's something that you can use in exactly the same way, where you take your students on a tour, you explain it something to them. You're either in the same room, or because everything goes to a server anyway, they can actually be anywhere. So you can really take anyone you like onto that trip. And
they can hear
you, and you can hear them. So if it is really about asking questions and then getting responses, so that is basically technology that's there. That is not a problem at all. If you want to integrate this into an experience that is standalone, so where the student can go to the library, sign up for an immersive experience, because, for example, for some parts of the experience you need sort of the high and interactivity that only an HTC Vive room scale experience would allow, then there will be possibilities for that, but that's probably a little bit further off. So if you look into, for example, speech recognition and simulation training, then there are already a lot of opportunities that the more constrained the question answer sequence is, the easier it will be to realize that. So if you have a completely open conversation, that's, I think, far off. But if you have a certain sort of idea of what the responses should be, even as a conversational sort of agent that you can implement, that's already possible. So, but it's not like completely flexible. So if they have a question that's completely out of the blue, unrelated to anything else, related to a movie they watched last night, then of course there's no system that will be able to answer that. But sort of within limitations, conversational agents actually have come a very, very long way. and would allow you to actually mimic, or at least mimic some of that, that as well. But if you are happy to be in the room and you can take the students with you, then that's already technology that's there, that's also not even confined to a single location, but you can do it at different locations. It's actually one of the things that at Penn State has a lot of appeal, because Penn State has the main campus, and then it has 23 satellite campuses across the Commonwealth, and they sometimes have very, very different learning experiences. So having something that creates centralized kind of material really allows us then in this form to share it, because they either need to sort of adjust their scheduling, which might be like a very way too demanding task, but it could also be a resource where the faculty can then send students to a dedicated VR room, and they still can have at least sort of somewhat of a field trip, even though it's not an actual field trip, but they can have a shared experience, or an experience that is the same at other campuses as well.
And then the other thing, and I'm sure all the geologists complain to you about it,
Yes.
one of the things I think in the physical sciences in general is touching things,
Yes.
also making observations on your own.
Yes.
So you have the case to kind of measure things, but
Yes.
a big part of geology is we'll show up
Yes.
and I'll say, make a sketch of what you see.
Exactly. Yes.
Is there a possibility
Yes.
to do that while you're wearing one of these
Yes.
contraptions?
Yes, so there are lots of different so this, yes, perfect, spot on. So the questions and responses that we have, and we put it on our to-do list and agenda. So there are options for note keeping. Again, it depends on if you have a fully immersive one. You really don't want to start sketching with. I mean, there's Google Tilt Brush, right? So you can sketch like wild in 3D, for example. There's ways of like doing that somewhat on a notebook as well. What I think is a better opportunity for these kind of exercises is actually going to sort of the mixed reality version of that. So even when you have sort of the system such as either an Oculus Rift or an HTC Vive, you can have like little cameras that you put to the front that basically stream directly sort of the room content to the student. So you can have a desk at the side where if you have a sketching environment, you can actually reuse the normal sketching or the normal handwriting that you do, which is tremendously more sophisticated than anything that you have digital at the moment, at least if you have sort of fine-grained one. So that is a possibility that you can explore. The other possibility is to have sort of like you have in lots of computer games as well, you have sort of this ability to have a camera with you. You can take pictures and you can select maybe from a prefabricated way of sort of annotating the pictures. So if you can just select from a text, like copy and paste, put it into your own notebook and keep the items in there, then that's of course a possibility as well, but it's not the actual activity of sketching something. Yes, so there are solutions, and these are the questions that we also get. For the touch one, it's the same thing. So it's a way of having basically a mixed reality experience. So if it's important to feel, for example, different grain sizes, ideally you would have a rock somewhere that you can integrate into the experience. And again, the two versions of doing so would be to either have a mixed reality experience where you can basically have at some point just a video stream sort of to you, or if you go super high end, you can have a HoloLens, for example, and use that and have the actual rock there. Or you can create a digital version of the rock as well, attach a sensor and basically have the rock and you can pick it up. You would see the rock as a 3D model, for example, using structure from motion, but you have the sensory input through your hands as well. So there are solutions. Again, if you think about that's why we have the sensatium, right? So this is where we try to sort of maneuver at the moment. So we can do all of those things, but they come at a cost. So the question then is, so for which learning experience do we actually need these, and which learning experiences are perfectly fine with just sort of the more basic versions? Thanks.
Great. I'm just going
Yes.
outside.
Yeah, no. Actually, the strange thing for me is I was a lab rat, And then ever since I do the immersive experience, I actually go on all these field trips. So so that's yes. So yes.
Yes, yes,
Oh.
yeah. Go further.
You talked about the novelty piece of it.
Yes.
When people couldn't say, aha, because you have experienced it. And
Yes.
you saw different kind of learning outcomes. Have you considered the age issue? I know you have students and the
Yes.
cohort is kind of perhaps not very diverse, but
Yes.
we had also experiment with the class here on diversity in PRTM, and there were a couple of kind of older